I'm bigger than the ocean. I'm in the sunshine state of mind. I want this feeling forever. You want to
So this is a free body diagram. So this is a box laying on the table, flat surface. The bottom force is gravity force, which is equal to normal force. The next two forces are applied force and friction force. The box in this picture is sitting on a table. If the table wasn't there, gravity force would cause the box to slowly fall until it hit the floor. But because the table is there, the table has a normal force pointing against gravity, which is keeping the box from falling through the table and going to the floor. Applied force would be if this guy over here was pushing the box to the right. And friction force would be the table rubbing against the box, trying to keep it from moving. Now let's take this as an example. There are 120 newtons being applied to this box on the table. 60 newtons of friction, the opposite way, trying to keep it from moving. Now, what's the net force? Now that we know what net force is, we can find the net force of this box. We take the applied force minus the friction force to find 120 newtons minus 60 newtons, which equals 60 newtons. Now we're going to see how to apply this formula in solving for the net force. So we have a box. The normal force is 640 newtons. The gravity force is 800 newtons. So we have information saying that the mass is 80 kilograms and acceleration is 2 meters per second squared. This is our formula. Force equals mass times acceleration. We plug in the numbers. 80 kilograms is the mass. 2 meters per second squared is acceleration. Multiply these two, we get 160 newtons as our force. A way to quickly check if we got the answer right, if this equation really worked, is to use the same thing we used just a couple minutes ago. To find the net force, we take the bigger force, subtract the other force to find the net force. This is 0 6, and 1. I guess it was right. They match.